Hey Spread World, it's Rob, and one of the more common questions I get is, what are you doing in my house? But besides that, what is this device hanging on the side of the wing? And this is an aerobatic sighting device. We use this in competition aerobatics in order to place the aircraft where the judges are expecting us to be, either on a horizontal line, a vertical line, 45 up, upright or inverted, or 45 down, upright or inverted. And we do that by placing these angles here onto the horizon. So you'll see pilots, as they're flying through their routines, they're looking to the left and they're looking through these sighting devices. Well, some airplanes have them on both sides. 300 Bravo Lima only has it here on the left wing, and that's fine. It works great. And the other question I get is, what is this string? And a lot of people think, oh, it's angle of attack, or it's attitude, or it has something to do with where the aircraft is pointed. And no, it doesn't. We really only use this one time, and that's as an airspeed indicator. So as we're going fast, well, the thing is straight out. As we get slower, it kind of waves and wiggles and things like that. But in a tail slide, we need to go up, stop, and then back up. Well, we don't know when that transition actually happens. There's no sensation in the aircraft as to when the airplane's now going backwards and the controls are reversed. So we need a visual cue. The airspeed indicator really isn't doing a whole lot below 30 knots anyway. It's just 0 for a while. So when the string flops and wiggles and then reverses and goes this way, we know that we're going backwards. All the controls reverse, and depending on which way we want the airplane to slide, either canopy up or canopy down in the flop, well, that depends on where our control inputs need to be or where they need to go. So normally for nose up, we would pull, but in this case, we need to push because the controls are now completely backwards. This particular piece of yarn has been on the airplane since 2022. And really it's just that, it's just yarn. There's nothing special about it. A lot of people use shoelaces, things like that. I was out at Walmart and I saw some really bright orange paracord, and so I'm going to replace this old worn out string with some paracord, a little bit more durable, definitely a lot brighter, and I like it. That's it. So we're just going to cut this old one off and put this new one on. This particular sighting device was originally with the aircraft when it was purchased back in the 90s by the Northern Lights Aerobatic team. And it had this basic design, but it was a bit smaller. So this piece was very long. And the 45 line here only went from about here up to here. And so in episode 2 of the Flight to a Championship series, or episode 3, excuse me, Flight to a Championship series, Tom Sherwood, out in Beverly, a longtime machinist, welder, parts designer, engineer, welded up the new bigger sight, making it easier to see. And so with it being a little bit bigger, you get more resolution. You get a better sight picture when you're out there in the competition world. And so you can be more precise with where you're putting the airplane. And this is made out of aluminum. A lot of the ones nowadays, the more modern ones, are made out of carbon fiber. And one of the easiest places to source strong materials that are carbon fiber for sighting device production is hockey sticks and carbon fiber arrows. So a lot of the modern airplanes that don't use this tubular design here, they're using more rectangular or boxed mount, and the carbon fiber hockey sticks are the perfect size to go mounting on an airplane. So a lot of folks are using that right now out at nationals, which are happening as I'm recording this. Jeff Petroselli is one that I know of, is using a hockey stick and some arrows that he cut up and epoxied together and made sure they were all the right angles. And you can make them really, really big. Let's go, how far do I want this to go? Let's cut it a little long here. And then we're gonna leave that nice glued end. Yeah, I think I'll shorten that up to right about there. I think that'll do just fine. So let's cut it here. We're not going to need a lot. And so we got a ton of paracord sitting on the ground that I'm never going to use. But yeah, so they make them out of carbon fiber, epoxy them together, and then you don't have to worry about if something happens to it, it breaks, gets damaged. You don't have to worry about welding or getting fancy materials and parts. Like, it's literally carbon fiber arrows and some glue. Really nothing to it. And then affixing this, I'm not a Boy Scout, so I don't really know my knots. Let's see, how do I want to do this? Well, we did that around there. We should probably do something along these lines, something like this. If you don't know knots, tie a lot. I think that's the same. There's probably even a bit of kind of winding that I could do and make it go back upon itself. Let's see, so like we're on the right track there. What if we did... Anyway, that's an answer to one of the most common questions we get about, you know, what this device is. And so when you see these on other aerobatic airplanes, they are not for doing pull-ups. They are not for hanging your wet towels or anything like that. They're supposed to be on very specific angles, and if they get knocked out of those angles and out of alignment, now we could be flying the aircraft potentially off angle, and that would lower our scores, and that's not what we're looking for at all. So if you're out at an air show and you get to have an up-close encounter with one of these airplanes that has a sighting device, just please be respectful and don't mess with it. Okay, I should get some glue on here and really make sure that's not going to go anywhere. But that's it. That's how simple this is. All right. So another frequently asked question is, what are these? Well, this is a spade or a shovel, and it's easily described as power steering for a car, but there's even a little bit more to it than that. So we have a full span aileron here, which really is at 200 knots. It's a lot of surface area, taking a lot of different load. And so as you deflect it into the upper part of the top airflow of the wing, which is going faster than the airflow on the bottom of the wing, you would have more resistance on the upward deflected aileron than you would on the downward on the other side. And so geniusly, they developed these spades, and so as you deflect it more into that airflow up top, this deflects into the airflow at the bottom, neutralizing those forces. But wait, there's more. So we can actually tune these to have different control, feel, and responses at different degrees of deflection, depending on what the pilot wants, by adjusting how many washers are underneath these bolts here that attach it. And so from the factory, this thing is actually very, 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 very neutral all the way through the speed range and all control deflections. There's very little loading on the stick. Well, that's cool, but it makes the aircraft very twitchy. Any little tiny input that you give, the aircraft will show, because it's a very responsive airplane. And so what I've done is I've added a little bit of deflection here in order to increase the amount of centering force I feel in the stick. So when I bring it back to the middle, it wants to stay there and not overshoot and not wiggle. It wants to be right there. And there's a side benefit too if you go even further with this deflection. As you deflect the ailerons past the center, this actually starts to scoop extra air and causes these ailerons to go to full-scale deflection, which is where I want them to be for the majority of my aerobatic flying anyway. I want them at full scale. So anything from a half out, it's actually helping me to get to full-scale deflection. So next time you see one of these, please don't hang on it. It's got a purpose on the airplane. Okay. We were just talking about the spades on the ailerons, and the rudder actually has something very similar. It's got a horn here that deflects in the opposite direction as the rudder's deflected, and it does basically the same thing. It scoops some air in order to neutralize some of the loads that are acting on the elevator, or the rudder, excuse me, that are acting on the rudder in order to give it better feel and reduce loads so that we can more easily deflect them. Because in the aerobatic world, again, just like the ailerons, we're using full-scale deflections of the rudder, and so we don't want it to be fighting us in order to do that. But this is very well tuned. On this particular aircraft, it's one of the original designs, and we don't have horns on the elevator or on the ailerons like the 330LX SC and the new SX have, and even the NG. So the SC has elevator horns, but it's also got a much larger elevator, a lot more surface area, a lot more control authority there. And so those are just some of the designs that were changed as they generationally grew and matured as an aerobatic machine. So some really, really neat things going on with these airplanes. Have you ever seen an aerobatic airplane having smoke come out of it? How do they do that? Well, it's pretty simple, actually. The extra aircraft, pretty much all of them, have at least 3 fuel tanks. The SC has 4. That's pretty neat. And this particular one has an extra tank, and that's just designed for holding smoke oil. And it's right here up on the top. On some other extras, of the later extras, that was actually converted into a fuel tank, and you had a different way to load the smoke oil in, usually through a pickup on the bottom, and it would suck it out of a bucket or a container or a drum, something like that. But once it's in the tank, another little electric pump takes that smoke oil and injects it right into the exhaust using these lines right up here. And it's just oil blowing into hot exhaust, and then it comes out and it makes a mess of the belly. Well, making that smoke doesn't come without penalties. It actually costs about 1 horsepower because the expansion of that smoke inside the exhaust actually creates a restriction, which that restriction prevents the flow of air and gases coming out of the engine. And the engine is just an air pump, and any resistance to that pump will slow down that flow, and so can actually cost you a little bit of power when you're turning on the smoke. But this has 2 nozzles here injecting oil into that exhaust, and that makes really good smoke. If you have any other questions about the extra 300 or any of the other extra aircraft, feel free to put them down in the comments, and maybe I'll make a video about those too. But until next time, this is Rob with Spread Aviation. Take care and fly awesome.